Okay, welcome to Accelerated Math. This is graph inverses of linear functions. Alright, these couple of steps here. We need to first of all figure out what the inverse of this is. Here's the original function, and the basic steps for finding the inverse of a linear function would be to replace f of x with y. So we're just going to replace that with y. And then we're going to switch the two variables. We're going to switch them around. Y is going to go over here, x is going to go over here. So it becomes x equals 2y plus 3. Now we're going to solve for y, the new y. Alright, so we're going to minus 3 to both sides. Of course, x minus 3, those are not like terms, so you have to leave it like this. And then we're going to divide both sides by 2, and we have to divide this whole thing by 2. So it's y equals x minus 3 over 2. And if you had a multiple choice practice like this, that might be the answer. But we've got to look for the graph of it, and this is not really completely in that y equals mx plus b kind of format. Look at that 2 down there in the denominator. You really need to split it out. It's y equals x over 2 minus 3 over 2. Well, there's a 1 in front of that x. It's kind of an understood 1. So you can write this also as 1/2 with an x kind of out to the side here, not in the denominator, but either in the numerator or out to the side, meaning multiplying it by that, and minus 3/2. Now we have it in this y equals mx plus b kind of format where we can easily identify the slope and the b value or the y-intercept. So let's take a look at the graphs and find out, well, the first step is which one of these graphs crosses at 3/2 or negative 3/2. So we can rule out anybody that's crossing up in the positive area, so it's not those two. And here, if you look at 1.5, 3/2 of course is the same as 1.5, so that's like minus 1.5 or minus 1.5. Okay, so it's crossing here, and this one looks like it's crossing down at 2. So I'm going to rule this one out. Let's double check on this one. If this is at half, it should be going up one unit for every 2 that it goes over. Up 1 unit for every 2. It's a little hard to work with that fraction, but that seems like it fits. Alright, so the key there was finding the inverse function and then making sure you had it in this y equals mx plus b kind of format so you can identify which graph it is. Alright, and then determine whether the inverse functions are graphed on each coordinate plane. Now here's the deal. Let's say this is our original function. If this is the inverse, it should be a mirror image over the parent linear function. You might be saying, I don't know what the parent linear function is. The parent linear function is y equals x, or f of x equals x. And that was something kind of like a math 1 kind of thing where you had to have the parent function. So here's the parent function of y equals x, and it's just 45-degree angle right through the origin. It's going up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. It's really easy to graph and identify. And if the original function is an exact mirror image of the inverse over the parent function, then it's correct. Okay, so then this is a yes over here. So this is a yes. So it's either one of these two. Let's check this one. Again, here's our parent function. It's going through the origin, going up 1 over 1, up 1 over 1, or down 1 over 1. And it does appear to be a perfect reflection. So that parent function should basically cut your paper in half where you could fold it and you would have a perfect mirror image there. So this is a yes, yes. Yes, yes. Not a yes, no, or a no, yes, or a no, no. It's not a no, no. Alright, let's see if we can get a no, no out of this one. I'm just kind of looking at this one visually. It looks like it is, but I'm going to put in that parent function, make sure, and whoops, didn't draw it very well, but yeah, I would say that's a yes. This one, I can kind of look at this one and go, no, that's not going to be a mirror reflection. And you can see it is not. So this is a yes, no. Alright, and that's it. Those are not too difficult once you understand that parent function of the basic linear equation right here and just trying to find that mirror reflection.